Hey, welcome to Make Sense of Math. I am Michelle, and today we're going to talk about the best way to teach exponent properties. I have found helping students make sense of exponent properties is the best way to help them retain the information. If they just have to retrieve a rule that has been taught, it's not going to be as effective. Now I'm going to show you some notes that I have to teach exponent properties. These are the notes that I wish I had when I taught middle school math, but I kind of hand wrote because I didn't have time to make them. But now that I have more time, I have made them to help middle school math teachers. The first thing you want to do is help students understand what the expression is saying. I always start this by going back to the basics. So if they are learning, for example, x to the fifth times x to the third, and they have to simplify that, I'm going to start with x to the fifth, and we're going to remember, what do exponents mean? Exponents tell us that we are multiplying a base together so many times by the power. So for example, x to the fifth is going to be x times x times x times x times x, right? Now, if we want to do x to the fifth times x to the third, we're just going to do the same thing. So that is saying that we have x to the fifth 5 times and x to the third 3 times, and then the students can figure out that's the same as x to the 8th, right? And we would do the same thing here, a to the 8th times a squared, and we just do it again, a to the 8th, well that's 8 a's being multiplied together, and a squared is 2 a's being multiplied together, and all that multiplied together is a to the 10th. And I would do more and more examples of this, just writing them out. And then I would say, okay, writing it out is a great strategy, right? It's something we can always do if we don't remember like a rule that we're going to discover. So we said, well, if we don't want to write it out, what's a connection that we could do, or what's a shortcut that we could do instead of having to write it out? And I would have students look for a connection between a to the 8th, a to the 2nd, and a to the 10th. Or what's a connection between x to the 5th, x to the 3rd, and x to the 8th? Eventually they're going to realize, well, that's just the same as adding the exponents. And then we would say, oh, okay, so for example, if we have x to the m times x to the n, then you're going to say that's the same as x to the m plus n. And that's the hypothesis. And then we would do more problems and test it. We would test it with a hypothesis, model it out, and see if it works. Let's go on to another example with properties. So now if we're looking powers to a power, we start with the same thing. We have to go back to the basics and go, okay, what does x squared to the third mean? Well, it means x squared 3 times. So if I'm writing x squared, x times x, I'm going to write it 3 times. So xx, and then xx, and then one more time xx, right? And we'll say, oh, okay, well, that's the same as x to the 6th. Okay, great. Then we do the same thing. A to the 6th to the 2nd. What does that mean? That means a to the 6th, so 8a. We do that again. We write it here on top. Okay, and what's another way to write that? Well, that's the same as a to the 12th. And then again, I would do more and more examples, and then I would say to the students, great, now writing it out's a great strategy if we don't know what to do. But sometimes you don't want to write it out. Sometimes the numbers are going to be very large. So is there a connection between my exponents here in the part of the problem, x to the third, x squared, x to the third, and to x to the 6th? And is there a connection between I kind of covered it, a to the 6th, a second, and a to the 12th? And eventually someone's going to say, oh, that is, 2 times 3 is 6, 6 times 2 is 12. And so the hypothesis becomes x to the m to the n is the same as x to the m times n. And that's our hypothesis, and then we would go test it. I would give them more problems. They would say, okay, use our hypothesis first, then write it out, and do you get the same answer? And then they say, yes, oh, we got it. And so then let's go on to a different one. So this is the same thing with dividing fractions. You're going to maybe need to review that anything divided by itself equals 1. So for example, 2 divided by 2 equals 1, x divided by x equals 1. Right? So we're going to write this out. X to the 5th, we're going to have, that means that there's 5 x's on top and that there's 3 x's on bottom. And we are going to simplify this. X divided by x is 1. And I would say to my students, I could write 1, but I don't really need to, right? Because I know anything times itself, anything times 1 is that itself. So maybe I would start writing 1 at the beginning just so they don't get confused. But have a conversation with them that that's not necessarily necessary. X divided by x is 1, x divided by x is 1, and what do I have left? Is x divided by x. So that's the same as x squared. Then I would do it again. A to the 8th, so I have 8 A's on top and 7, 8 divided by 2 A's on bottom. They cancel. What's that the same as? It's A to the 6th. Then I would do more problems, and then I would have the same conversation. Oh, it's so good that we can write this out and get the answer, but we're not always going to want to, or the numbers are going to be so huge that it's not going to be efficient to write it out. So let's look for a shortcut. I'd ask them, what's the connection between x to the 5th over x to the 3rd and x squared? And the same thing as a to the 8th over a squared over a to the 6th. And if they don't notice that, for example, 8 minus 2 equals 6, and 5 minus 3 equals 2, I would give more and more examples and help them to look for a pattern. They will eventually get it. I would do the same thing. I would write it generalized. X to the m over x to the n equals x to the m minus n. We would test our hypothesis out with different questions, see if it works, and then we've made the connection with the rule. With negative and to the 0 powers, the way that I teach it is I create a table. So x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. And they would notice that the pattern of those is dividing by x, and it will eventually lead to x to a 0 is 1, and then x to a negative 1 is 1 over x, and the pattern will continue. So that is in my notes as well, is finding those patterns in a table. I like to teach it this way because students always have a way to figure it out if they forget the rule. As they go to do fluency papers and to practice these exponent rules, they're going to say, is it add, is it subtract, is it minus? And I always say to them, write it out. If you don't know, write it out. And then I guide them to remember the rule, and then they have it. It'll be a lot of like writing it out at the beginning and remembering the rule, but they will eventually get it. And it's so good to have a tool to always fall back on. And just a little note with fluency practices, I always start the fluency practices with small numbers so that if they need to write it out, they can, and it's, not going to take so much time. Towards the end of fluency practices, I do a little bit bigger numbers, hoping that they get their role, because that's eventually where we want to take them. So this is how I teach exponent properties. I found it to be the most effective because students understand what the question is asking. They have a tool to figure it out, and they have a shortcut to apply when the numbers get bigger. So these are my notes. You don't have to use these notes, but if you want them, I will put them down in the description below. Thanks for joining us. See you next time.